Welcome to the presentation of Compression Understanding of Industrial Data Standard. The name of the standard is Mpai Cui, Compression Understanding of Industrial Data. And in particular, the company performance prediction, which is now version 2. But before getting into the details of the company performance prediction, let me give 2 words about Mpai. Guido? So because Mpai is about standards for AI-based data coding, and what does this mean? It means that Mpai breaks up a monolithic AI application into subsystems that interact the exchanging data with the known semantics, so that developers can compete, offering standard component, possibly with improved performance compared to what is around. So it is a kind of Lego type approach where we have applications that we call workflows, that are composed of modules, AI modules, executing in the environment that we call AI framework. Next slide. So by means of this, we are able to create dynamic configuration, initialization, and control of AI workflows executed in the standard AI framework. The structure of the standard is architecture, metadata, this is very important, common APIs, features for 2 types of API, basic and security, and then profiles. Next slide. So this is a very simple representation of the AI framework reference model. As you see, we have green AI modules that receive data and produce data. The data are connected to other AI modules. We have an environment with the possibility to store locally information in secure, non-secure way. Essentially, we activate the controller, and then we can access to different functionalities through API. So this is just to give you a very simple introduction to show you how the standard does indeed rely on this module in the way that Guido will explain. Guido, please.
Thank you, Leonardo. Thank you to everybody for being here. So this is the content of that presentation. First, we introduce you in general the standard. Then I'll give you some details about the applications, some of the applications of the MPAU AI CUI standard. And I'll show you a small demo with anonymous data just to show you which might be the practical outcome. So the standard, the company performance prediction standard is a way to predict the performances of a company. The big difference with the previous version is that we don't focus just on financial and governance risks from the AI point of view, but we also integrate different families of vertical risks. In fact, a proper taxonomy of the other risks is introduced. And in the present version, we integrate, as an example, the seismic and cyber risks. It extends the previous version in 2 ways, the functional and the regulatory point of view. Which are the novelties? So First of all, it's able to extract data from a larger set of data. So it can integrate data which are coming from different sources. The prediction is still up to 60 months, as in the previous version, differently from the previous version where the horizon was 36. And we are considering both the cases in which a proper AAM is defined for a certain risk. Why that? Because we might have that we have a proper AAM, but we cannot use, as we will see later, for reasons which are not related to the AI system itself, but for regulatory reasons. For instance, an AI that can be used in US but not in Europe. In that way, the system is more robust and can give an answer in any case. If the AAM is available with the proper AAM, otherwise with the old system already present in the previous version, which is using a perturbation matrix coming from a self-assessment of the company. Moreover, we introduced an explainability which is compulsory. So it's not just a matter of predictions, but the predictions must be explainable in terms of the data which are provided as input. But I mean, let me give you some definitions of what we mean with performance. Okay, because we have different types of performances in our system. So the default is the probability that a company will default, so will have a financial crisis or serious financial crisis or bankruptcy in a specified number of future months. And explainability expressed as impact caused by the company default, caused to the company default. Organization is the adequacy of the organizational model and its explainability. Why organization is different from default? Because you can have that your company is financially perfect, but your organization has some issues. Those issues might cause in the future problems. In particular, for instance, think to the COVID-19 disease. In that case, there was the need to take decisions very quickly. If you have some types of issues in the organization, you might have problems when you have to take decisions in a short time. Primary default is the probability to have severe financial distress. Primary discontinuity, the probability that you experience a specific risk effect. For instance, the climate, the cyber, again, given a certain time horizon. And then the secondary ones, the probability that an interruption is due in the case of a risk for which a proper AAM is not available or is not compliant. So as I was saying to you before, this is one of the biggest differences with the previous version. We have a sort of double path. One path which is, let's say, the normal one, in which we have the proper AAM. But we still have a secondary path that is able to make a prediction which is less precise than the primary one, but in any case is able to do that. Why that? Because as is written here, you might have that for a specific risk you don't have an AAM, or that the AAM cannot be used in your country. So you must give in any case an answer to the company. This is just a summary. I want also to stress that the fact that we are stressing so much the regulatory part is because we are introducing explicitly some metadata about the regulations to which every AAM is compliant. And this is very, very important in general, not just in CUI, CPP, to be sure that you can legally use your AIM. And this is something that is becoming more and more important now that the different regulations appears and they appear and they are quite different each other. This is the workflow. As you can see here on the left, you have all the inputs, the descriptors. We have that big block, company assessment and prediction, that as we will see is not an AIM but is a macro AIM. And as I was saying to you before, if there is a risk, a family risk, for instance, cyber, but can be, any kind of other risk which is available in the, which is defined in the taxonomy of the risks that we also introduce. A secondary statements are give to risk matrix generation as in the previous version, and from that to a prediction result perturbation, which is using what the descriptors of the primary default and the predictions, financial and governance predictions from the previous step. Here in output we have the organization descriptors, primary default, primary discontinuity, and secondary discontinuity probability. As we will see in a while, those are now descriptors because those are becoming more and more complex structure due to the fact that now we oblige the system to give an explanation an explanation of the prediction. From the workflow point of view, this is again a recap of the inputs and of the outputs of every block. But just to sum up in an easier way, those are the functionalities. Governance assessment, so computes the governance descriptors from governance and financial data. Financial assessment, risk matrix generation, and the fourth one, which is the one on which I want to focus, the assessment and prediction, is a macro AIM that computes organization, the default one, so the primary, and the discontinued descriptors for also for the other vertical risks. This is the depiction. Is made by, in practice, two blocks which are compulsory, the primary default and the organization model assessment. And then there is this third block, a primary discontinuity prediction, which is actually made by several AIMs, one for each vertical risk, in the present version, climate and cyber. But tomorrow we might have other risks. For instance, I don't know, ESG or other types of risks. This means that this block actually is composed by several AIM. One, at least one for each vertical risk which is considered. Why at least one? Because as I was saying to you before, you might have that a certain AIM is usable in Europe, but not in the US and vice versa, or in Asia. This means that you might have several versions of the AIMs, one for each regulation. Why that? Because in some regulations, for instance, you can use some data and in some other ones, no. You don't have the permission. Think to the GDPR in Europe, for instance. So this means also that actually this green block is actually composed by several blocks in parallel, which are creating at the end these primary discontinuity descriptors. This is just a recap. Okay, so now focusing on the primary discontinuity prediction, we have now two different types of vertical risk already proposed. The cyber is the first one. So cyber risks and the climate one. In both the cases, the proper descriptors have been defined, starting from the state of the art on both the vertical risks. As I was saying to you before, as in the previous version, where this was the only way to make a prediction for risks that were not financial or organizational. There is still that prediction result perturbation that takes a self-assessment of the company, creates a risk matrix, which is a matrix that says for each family of risks what is the impact, expected impact on financial and governance, and then is computed a probability of discontinuity. In that case, it's just the probability of discontinuity because one for each risk which is considered, because we cannot we don't have a proper AIM. We are just perturbing the existing ones, trying to see what is the effect, the secondary effect on financial and organizational distress. Okay, this is a recap of again of the input and output. In particular, as you can see, governance, financial, and risks are still risk assessment are the same of the version 1.1, while the other ones have been extended. In particular, I want to focus on the new descriptors. The new descriptors are done how? There is an impact, the impact of a specific risk, which is a real number between 0 and 1, and the descriptors impact, which is a vector of the impacts of the input descriptors. So for each ID of a descriptor, there is an impact which is another number between 0 and 1 and it expresses the let's say the importance, the weight of that descriptor in explaining the impact of the risk. This is, for instance, the example of what we have for the climate. So the impact, the vector, and inside the vector, couples made, so a matrix made by ID and impact. As I was saying to you before, this is one of the big differences with the previous version, because now it's compulsory to have for every AIM a proper explanation. So we are forcing not only the regulatory part, but also the explainability. And this is crucial in some applications, and we hope that will be made compulsory, because otherwise, I mean, in many applications, I think applications like to the risk ones in that case, just having, let's say, the prediction is nothing, because you need to know how the machine decided that you had that impact. Because you might have two different companies with the same climate risk, but explained in a totally different way. Okay, so what's next? The risk taxonomy for the moment is in a, let's say, first version. What we need is to find a more detailed risk taxonomy, in particular related to the AI which are present in the literature. They are starting to be present every day. There is something new. Why we need a risk taxonomy? Because there are some tentatives taxonomies in the literature in other standards, but the problem is that sometimes it becomes difficult at a certain point when you see, let's say, the risk structure of a company to understand, to compare two different reports, because how the risk are let's say defined is different from one standard to another one, and we need a way to, let's say, also to qualify the AIMs properly. Okay, so now I want to show you a little bit the applications of MPA CUI. So who might use that the let's say applications based on our standards? So company boards, because they need something to develop efficient strategies, identify the reasons of a crisis, and decide which is the path to have a recovery, to conduct what if analysis. Bank and financial institutions, because they need to evaluate their portfolios, and which might be, and that has been already proved in a paper with the regional government of Piedmont, you can use the AIs, including in the standard, to perform a let's say a what if analysis on the, for instance, on a regional on the regional government or on a bank, if they do something for their portfolio. And as I was citing now, also public authorities. If you think that now when they decide something is decided according to some statistical data, they are not tuned on the actual companies that might be interested in some heights or regulations. In particular, this is the example that I was citing. We used the system to evaluate the impact of the funds given to small and medium enterprises. And why? Because having the possibility to have a forecast up to 60 months, you can simulate what would happen to a group of companies. So you can also, I mean, you can see if it's worth it or not, but also to define some parameters of your intervention. Because I don't know, what is the right percentage in terms of money? What kind of intervention is better than another one, given the structure of the specific companies that on which you are making the intervention? For instance, if you know that they are not just small, medium, but they belong to a certain a certain industry, for instance, thinking to the automotive, for instance. So this is a very important application, because you can do exactly the same on the portfolios of banks and insurances. For instance, if you want to know what is the impact of having some types of insurances on agriculture, to give an example, when you let's say create insurance structures for them. So how let's say the final application should be like? I show you a decision support system based on the CUI CPP. The idea is what? That you compute instantaneously the primary default, so the default probability, and the organizational one. Just put in the VAT number, because with the VAT number we can have almost instantly the data from Camera di Commercio in the case of Italy, or from databases like Orbis, and you can immediately compute at least those ones. Then, according to the data that you have and the risks, vertical risk for to which the company is interest, you can also have the vision for the other vertical risks. Then you can view a report. You can fill out a survey that will be used for the secondary risk matrix, so to evaluate all the risks for which you don't have an AAM. You can obviously delete the company or change the company registry. So, what will see, imagine a CEO or a CRO of a company? First, you'll see that, for instance, you will have some maps related to your risks. In that case, is the cyber risk, giving you what the impact and the occurrence of your risk, in that case the cyber risk. So imagine if you can do that for all families of risks that you can think about. It means that a company can have a real map. In that case, you see that the scale between 0 and 4 in practice, but I mean, it's just an example. You can have an idea of, for different types of risks and sub-risks, if there is, let's say, a certain probability of impact on the business, and what is the occurrence, the probability that you will have that kind of problem. Then, if you think to a more high level vision, you can have some scores, which are in practice the impacts computed before. So the primary default, organizational model, and in that case also the primary discontinuity, which is taking into account all the vertical risks for which you have a proper AAM. So you have the AAM and you can legally use it. Okay, what forward? We want that you now help us to improve that project, because I mean, even if the version number 2 is a big step ahead compared to the previous one, for sure there is still work to do, in the sense that it's not just the matter of the taxonomy, but also, for instance, how to manage if you have several AAMs on the same risk. That can be legally used. I mean, what do we do in that case? We let the user to choose the AAM, for instance. For now, we have just one AAM for each legal strato. It means that or we have one AAM, for instance, for the climate, or we have, I don't know, one for Europe, one for US, one for Asia. But what if we have multiple predictions available, and they might be, let's say, flagged by the user according to the input that the company or the bank or the public body can have? Because remember that in some cases, if you think the seismic, for instance, or flooding, it is not just a matter of having an AI, but also if you have the availability of the proper inputs, which are in some cases very, very complex. Can be, for instance, the digital twin, let's say, of an entire building in some cases, because you need to know the shape of the building and the exact position and the exact conformation of the terrain around the building. And this means that we will need to manage very, very complex data structures, which is still not now present in the standard, also because there is no need for the moment. Thank you. I hope, yes, I was on time. There are questions?